Hello again, folks. Today we'll be going through Acl configuration. So this is basically carrying on from our last video where we set up OSPF, but what I've done is replaced one of the PCs with a server and configured it with an IP address and have configured our ITS PC and number 50 PC so that we can communicate across. And what we're going to do is two things. One is a standard ACL that we could use on the VTY lines. This will enable you to control who has access to the device. It doesn't matter which interface they come in on to the device, so we'll set it up on B1. So as there's two network cards active or interfaces active, you could technically enter via either of those, but there's a simpler way of protecting the device, and that's on the actual access lines themselves. So let's jump in to config terminal, and we're going to use a standard numbered access list, so it's between 1 and 99, so it's a standard IP access list, and we're going to permit, and we're only going to permit the host from the 192.168.60.10. Now we could change that to any host in the 60 network by backing that up and putting in the mask of 192.168.60.0 and matching the first 3 octets and wildcarding the last. So that means any ITS device can access the VTY lines rather than a specific machine. We'll go the more generic 60 network for this case. And now we go to our line VTY04, which is our remote access lines. And we want to put access group is the command you use for the interfaces. Access class is the one that you use for the lines. So our access list number is 10, and we want to filter the incoming traffic coming into B1. So that's applied. So if we do a show IP access lists, and we can see we have a standard access list with one line on it. So if we go over to our 50 device, we'll use Telnet because we didn't set up SSH, and we'll try to enter in via the 10 device, and the session's closed. We don't even get to prompt or anything now. So this is our 60 PC, so just to show you that, come back down to Telnet and connect to the same address. Helps if I put a decimal place in there. 254.10 connect, and we're in. So, and that is the other password. There we go. So if we show our running config, look at that. We scroll down to the end. There's our access list 10, and there's our line VTY class N. So very simply, by using a standard access list, we can filter the devices that can access the remote functions of a device. Very useful, very easy to do. Now let's exit, close the session, and now it's asking you, do you want to re-establish? So say no. Then close that off. Now we have a web page on 192.168.110.10. I think that's the right address. 192.168.110.10. Timing out. Alright, that's a problem. Can we get to the gateway? Nope. What about our gateway? Okay, so what about B1? Alright, so we've gotten to B1. Trace RT 192.168.110.10. We seem to have a bit of a loop occurring. So we're getting to our gateway and then getting to this interface, then coming back to this one. Okay, we've got nothing set here. That's a problem. We should have OSPF running here. Network 10.222. Area 0. So what? $192.168.19 because I didn't fix the addressing error. VLAN 10 should be up and active. So our routing process clear IP OSPF 10. Process 10. Clear them all, yes. Okay. 111. No switch port. 19. Show run. Bit of troubleshooting. So this is our LAN link. And where 19101. We don't have it as a member of the area. I mustn't have so we want interface G000. If we go into config T, interface G000, paste in our joining of the member. This is why you've got to save your configs, even in Packet Tracer. We now have a neighbor relationship with the switch. So I'll save that. And now, if we come to 50 and do our trace route, we get to 100.2. So roundabout way of getting there. So we go through that one, to that one, and to the... Yep, that's precisely where it's supposed to go. So now let's try this web browsing again. 110, 10. So as an extra bonus to this video, you got some troubleshooting. Cisco Packet Tracer web page is accessible from the 50 network, and Verbo 110, 10, and from number 60. So again, if we look over here on the actual server and go to services, you'll see that HTTP and HTTPS is on, and TFTP is there, and FTP. So what we can do is, how about we allow the 5010 device to only access the web server via 443 and no other traffic. So this device can access the web server, but only in the secure side. So we want to do this, and we want to be able to juggle this around. So bring in a notepad. There's my standard one. So access list 101. It's going to be a permit statement, and the protocol is going to be TCP, and the source is going to be a host address of 192.168.50.10, and I'm going to a host address of 192.168.110, and now I want to say equal 443. Have I got my port number for secure web correct? Only time will tell. Copy that, hit this one, and go OK, config T, and apply. And then we want to go to an interface. Let's go to 000, the outbound. It's closest to the destination. And again, why isn't so? It's going to be an IP access group 101, and it's going out. So now, if we show IP access lists, we have two. We have the standard one on our terminal lines, and now we've got this one. See, we've got two matches for that one, and we've got none for this. We'll come back to that in a second. So in theory, come over here to the web browser, and if we go 192.168.110.10 and go, what's going wrong? Because we now know HTTP, which is port 80, doesn't work. Let's see if it goes to HTTPS. Just like I bought one. So our ACL works. So we now have an ACL that only allows this machine to connect to our server using HTTPS. It's not a very good or realistic ACL, but it's one that's working. Now, let's refresh that. We've got 5 matches. Now, how about we change where it's applied? So, config T, interface G000, and no IP access group 101 out. Alright, now let's jump across to the inbound interface of 1. Now, if we apply this access group 101 inbound, because we are now on this interface going in, and helps if I don't click these things. So we're on this interface inbound to the device. When this comes up green, we'll try it again. So will it stop the traffic just like this side did? or will you have unexpected behaviors occur? I'll give you a spoiler alert as we're waiting for this. It's going to have a nasty effect. Okay, so we're up. Hit enter. I apply the line that I was on before these messages came up. So if I do a show IP interface G001, scroll up, we have an inbound access list of 101 on G001. And we've just had OSPF tear down. Why? So if we go back to our show IP access lists, we have 101 applied going in, and it's only permitting TCP traffic between these two hosts on 443. So what's happening is it's denying the OSPF. So this is why you should always try to test your ACLs in a non-production environment first, if you can replicate it. But it's also a very important reason why we want a notepad, so we can write things down and make modifications. So we want to add some more. Now I want OSPF from any source to any destination. So if I do that and step back into global config and do a new access list 101, so OSPF has come back online because we have no active ACL, because I just deleted it. Alright, so let's paste our new one in. Didn't get any caret symbols, so it looks like it's working. So if we do a show IP access list, we have OSPF and matches. So those hello packets are coming in, and the LSAs and things like that are being accepted. So it's not going to tear down our routing protocol anymore. So when you work on ACLs, you need to take into account all the traffic. You don't get focused on just permitting the task line. Okay, so you need to look at what other traffic is coming in that interface and what will your access list do to it. So you may need a combination of permit and deny statements to actually filter the traffic in the manner that you want it to filter. Because remember, at the end of this, line 21 is a permit. No, There is no more permit statements. Line 21 is a deny any statement. So if you want to get into the practice of reminding yourself that there is a explicit deny statement at the end of every ACL, you can just type in a deny statement at the end, and that will prompt you, telling you that there's an explicit deny statement. So any other traffic that isn't explicitly permitted is denied, which can have a major effect on your network's behavior. So we've applied a standard numbered ACL, applied a extended numbered ACL. Do the named ACLs get configured a little differently? Yes, but not by much. The command structure, IP access list, and then you say extended or standard, and you give it a name. So word name, I want a name of, what's my name? Testing. Boom. You go into named ACL mode. And what are your options? Well, you've got permit, deny. Alright. Sequence numbers. It will automatically use the 1020 gapping. So permit, deny, remark. So you can actually go through here like normal, permit, and then you've got the protocols. So if we want to replicate what we did, which was TCP, and we want host 192.168, so I'm just going to cheat a little bit and pull in what I had. There's our first line. There's our second line. And if I exit out of that named ACL list, it closes it. And now if I do a show IP access list, you'll see that I have my numbered, standard and extended, and now my named list testing. And that's the difference. So on that, I'll call it a done exercise. So we have a working ACL, and it's affecting the traffic the way we expected it to. So not any other traffic, including any IP pings or that, will come through here. So it's not a working solution for a production, but it highlights what we're doing. Alright, so no longer can use a ping to the web server. Destination host unreachable. The host exists, but you can't go there anymore. Here ends the ACL configuration exercise. Please have a play. There's many combinations that can exist. Just remember, an ACL must contain at least one permit statement, or else you're denying all traffic. Until the next one, bye for now.